Hi, I'm Sheldon McDonald, and I'm going to be doing a bit of a series of exploring assembly language on the color computer through the eyes of a beginner assembly coder myself. I had already done these videos, like two of them, but I seen that I had some issues with not being able to read the text on the videos and also I was kind of a little unprepared and ended up recording longer explanations than needed to be. um, so I'm going to leave the very first video alone, which was the just the introduction to getting your environment set up. That one's going to stay. The other two videos that I uploaded are getting replaced, starting with this one. Um, Being the replacement to lesson one. And I'm not going to be calling them lessons anymore. After one and two, I'm going to be calling them exploring, because really if I'm not really teaching assembly language, it's more that I'm exploring it as a beginner programmer that's programmed BASIC my whole life basically. Okay, so I'm going to start off by loading lesson one, and like I said, these are going to be uh, the ones after one and two are going to be actually labeled as explore. I'm going to go on the internet again to show you where you can get these files that I'm looking at. Um, so let's have a look here. Okay, so we can put www.smotion3d.net, and then it'll come up with a directory. I'm too lazy to build a web page, so it's just a directory. Click on the ASM tutorials folder, and you'll find the lessons that I've done. But like I said, they're not going to be labeled as lessons after one and two. They're just going to say exploring, 3, 4, 5, whatever. Okay. Um, and if you follow along with the YouTube videos, you can kind of see my thought process into making these files. Okay. So we're going to start off with my supposedly lesson one, which is supposed to be exploring. So we got the 60809 processor. It has the A register, the B register. The D register is just A and B combined, so it ties up both A and B. A has a value between 0 and 255, same as B, but when we use it as a double byte, D, combined, we have a value of 0 to 65535. Okay? And then we have the indexes. We have X, Y, and U. These can have a value of between 0 and 65535. We have bit flags that are used for conditional statements, conditional checking, like when we're comparing results like we do in BASIC. So if this equals that, then do this, or if that's not equal, then do this. Um, and when results from math equations, they can trigger bit flags to show that there's like a carry, or there's like a negative number or whatever. Okay. Then there's a few extra things on the processor that I'm not going to get into because it's more controlled by the computer itself. There's the S stack, and there's the program counter. Um, you can there is tricks, like once you become an advanced coder, you might be interested in learning that stuff, but if you're like me and you just want to program games or something, or simple programs in assembly, then really you're just going to be using these 6 items: A, B, D, XYU. Okay. Alright, let's look at a couple ways of loading values. We got LDA number sign 10. That'll load the value 10 into register A. LDB number sign $12. That will load the value 18 into the B register. So the $sign is telling the compiler that it's a hex number. Okay, so if you look at my bottom right hand corner here, you can write the value 12 into the hex word. It tells us the decimal value of that is 18. So this is a nice little handy tool when you're programming. It can help you convert numbers around. LDD number sign $400. This will load A and B, known as D, with the value 1024. And again, it's a hex number. If you put 400 into the hex word. Oh, my computer's lagging a bit there. So if we put 400 in there, then it tells us it's 1024. Okay. Now we're looking at the indexes. Okay, this is how we point to memory locations. We use A, B, and D to load and manipulate values, and we use X, Y, and U to point to memory where to store it and where to load it from. Okay, so LDX, number sign 1024. This will load the X register with the value 1024. LDY number sign $400. This will load the Y register with the value 1024. LDU 1024. Notice how there's no number sign here. This is to load the U register with the value located starting at 1024 and 1025 because it's a D byte. So if we had a known value there, that's what LDU will be set to, is the value located in those memory locations. Loading variables. So it's pretty similar to just loading numbers in, except notice we don't have the number sign. LDA cats. This will load the byte value located at cats in RAM. So notice how it's like this one, LDU 1024. It loads the value located at those memory locations. So same thing with cats. So LDA cats will load the byte value located at cats in RAM. Okay, I'm going to scroll down here, and in my little, actually it's already scrolled down. My little example program here, I have cats FCB. I'm going to highlight this. It says cats FCB3. So in memory, I'm accessing this number right here. Okay, and I can manipulate it that same way. So LDA cats, load the byte value located at cats in RAM. LDD dogs, load 2 bytes located at NB, located dogs in RAM. So, sorry, load 2 bytes A and B located at dogs in RAM. So if this happened to be dogs, we'll call this var right here. This var could be dogs, FCB 0 and 0. We've initialized 2 bytes for that variable. Okay. So it would be loading those 2 values into D. Okay. Let's see here. Where was I? Okay. LDX number cats. Okay. Load the address where cats is located. So if I wanted to reference a chunk of memory, you need the number sign. So if I was trying to get the location of where cats is in memory, I don't actually want the value, you would put the number sign. Okay, so LDX cats. So now I've got the X index set at wherever this assembled in memory. I have it sitting right here, ready to work with. Okay, LDY dogs. I did another just a regular one without the dollar, or sorry, the number sign, and that will load the value located at address dogs and dogs plus 1. So this is very similar to the LDD dogs, okay? The exact same thing, except you're loading the Y register with that value, okay? Storing values. STA $400. This will store the A register at 1024 in RAM. Remember, this is a dollar sign here, so that's hex. So you convert that to decimal, it's 1024. And A can have a value of between 0 and 255. Store B, 1024. So there's no dollar sign here, no number sign. So what's happening here is I would be storing B register at 1024 in RAM, okay? Store D, $400. Store A and B, which equals D, at memory locations 1024 and 1025. Most significant byte first, okay? STX, $400, will store the X index value to memory locations 1024 and 1025. Store Y cats. This will store the Y register value at cats and cats plus 1, where it's located in RAM. And like I said, when this program assembles, it doesn't even know where cats is going to be until it assembles it. And then it'll have a register it'll have a memory location once it's assembled. So your program will jump to that memory location to store values or load or whatever function you're doing. Okay, so I have a little example program here. I have it ORG, which stands for the compiler. It tells the compiler to originate where the program's going to start in RAM. So I just have ORG 3000. So technically that means it's going to originate the program at 12,288 in RAM. Okay. Start. I have the start of my program label. And at the very end of my program, I have an end to my start. Okay. So you can fit all your code in between, all your variables, everything, whatever. Doesn't matter. But you should have a start marker and probably an end marker for to help the compiler. So after I've put my label in, and you should tab delimit always. So if you're not using a label, you should hit tab before you write the command. Okay, so it keeps it nice and neat when you're looking at it. Okay, so right here I've got tab ORG 3000, and then I hit tab, and then I also put comments in. Okay, having as many comments as you can when you're coding is very good. It helps you locate problems in your code. Okay. Okay, so back to the start of the program. Start. LDX $400. Load the X value with 1024, which just happens to be the top left corner of the screen. LDA number 5. Load the value 5 into the A register. Store A, comma, X, plus, plus. Store A, which just happens to be the number 5, at the screen location 1024, because that's where the X index was, and advance the X index 2 places. Okay? LDB cats, that means it would load the B register with the value located at cats in RAM, and I got in brackets here 3. So if you look at cats in RAM, the value is going to end up equaling 3 because I have a 3 there. Okay. Store B 10 comma X. So store B with the value 3. to the X register plus 10 bytes. It does not modify the X register, and this is a nice trick that you can use when you're just trying to modify certain places in RAM without adjusting the actual index. Okay, this store B10, X is pretty cool because it can actually accept a negative value. So you can actually put -10 or or just put a regular number in. Just keep in mind that this number that goes here, I believe, is a 2's complement number. Or is it? No, maybe the assembler actually, I think, works on it. So you're probably good just to put the 10 in or the minus because it recognizes the minus and converts it for you. Okay, so the assembler should take care of that for you, so you shouldn't have to worry about the 2's complement stuff. Store X var. So what I've done is I've taken whatever value X happens to be. So really all we've done with 1024 is increased it twice. Okay, so it should be 1026. So I'm telling the program here to store var, load D, where am I? Store X at var. So when we look at var, right here in these 2 bytes, I'm storing the number 1026. Okay. Load DD var. Load the variable var into the D register, which would be var and var plus 1. So that would be both of those 2 bytes. Okay. I'm storing D at X. Okay, so I'm putting that value into memory locations 1026 and 1027. So these two values, when I look at it in BASIC, should equal 1026. RTS return to BASIC. If this was a subroutine, it would return from the subroutine and go back to your regular code. Okay, and my next example actually starts using some branching, so that's pretty cool. This is how you can define variables. They're basically just labels, just like your go-tos. Like I have start as a label. I could technically say BRA start, and it would create an infinite loop because BRA would branch always. var, so I've got FCB, and this is a way that you can put data statements in. The nice thing with LWASM is that you can stack data. On disk EDTASM you can't. You can only put 1 byte at a time. So if this was disk EDTASM, I would have to write another line and put FCB 0 to do the same job. So you can see how using LWASM is going to make your life a little bit easier. Okay. Cats, I have SCB3, and then I've got an end to my start. So that's the end of the program. The end of this video, I think I've made it a bit shorter, so that's good. I won't lose too much interest, hopefully, if I'm not rambling on about nothing. So we can take our program, we LWASM it, we can assemble it. Okay, it'll tell us if there's any errors. If there's not, it'll come up as assembled. We'll save the disk image on the desktop. Lesson 1, save. And then whatever emulator you're going to be using. Again, I'm using VCC because I've just got it on my computer already. We're going to have a look here. I'm going to change my drive. I have to eject the last one I had in there. I'm going to insert the file lesson 1, open. I'm going to dir to see if it loaded. It looks like it did, so then I can load M and lesson1.bin. and I can execute. Okay, so we got some bytes on the screen there. What I'm going to do is I'm going to CLS the screen. I'm going to execute it again, and we're going to take a look at what's in memory. So I can do that by writing question mark peak 1024. What's that? 1,000? Oh, sorry, I made a mistake there. Peak 1024. Oops, 4. So this should be the value 5. And if we look at our code to follow along, I'm going to pull this back out. Yeah, my computer's apparently a little slow. That's okay. Okay, so what did we do here? On the code, we started off by loading the value 5 right here. Okay, and then we stored it at X and then moved the X index 2 places. Okay, so if we jump 2 places, we should have our next value there because I believe we stored, let's see, store load B cats, store B 10x. Oh, so we've actually jumped way over here. So let's check that peak first. Oh, I'm writing on the wrong screen here. Let's go over here. And let's write peak 1,000. So if we, what did we do? 1,000. So 1,024, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. We're probably at about 37. Actually, I'm going to say it's 36, I think. It gives us the value 3. Perfect. So that's where we stored B at 10, comma X. Right there. Okay. We stored the value 3, and we didn't actually move the X index, and we're proving that by storing the X index. After we save the X index to var, we load it and store it where the X index was, which just happens to be here. So this D and B, if we put those together, those should equal the value 1,026. So this is how we're going to test that. So I'm going to execute it again. I want to print, I want to go question mark peak 1,024, 25, so 26. Okay. And we got the number 4, and we're going to peak the value 1,027, which is a 2. So theoretically, if this stored the number that is supposed to be there, I should be able to go print 4 times 256 plus 2, and that should equal 1,026, which it does. So our program has worked successfully. This is the first, again, it's labeled as lesson, but I want to start calling these exploring color computer assembly because I'm in no way should I be teaching it as a beginner, but I can kind of help from a beginner's view to kind of get started with it. I can show you how you can be testing values and such. Okay, this is the first video. Thanks for watching, and I'm going to redo that second video, and then I'm going to continue on with the Exploring Assembly Language series. I'd like to go over things like some hardware stuff too. Like I want to show people how to program the PSG, the programmable sound generator that Ed Snyder makes. And I also want to show programming the GMC, the Game Master cartridge, how we can get sound out of that thing through assembly. And I'm also going to be showcasing why you really want to be coding everything in assembly because it's just so much faster. The bits that I've learned already, I don't even want to look at BASIC anymore. It's just so much faster. Anyways, again, thanks for watching. Leave some feedback, and I'll try to take those notes and make my series better. Okay.